Check. Eight.
My mom is the grand total.
It's a really cool background photo.
I didn't even have time to study for my physics lesson.
It actually is pretty good. It does smell pretty good. It smells like lavender.
Okay, let's get started here with questions 1 through 3. We've got most of this already done, so we'll just go ahead and talk about it. All right, so for part 1, total number of packs of gum produced in a given day. Well, there are 2 ways to go about this. Okay, 3 ways you can go about this. First way to go about this is to go ahead and just add these together, find the row totals, add the 2 row totals together to get 830. Another way to go about this is to add the columns to get the column totals, and then take the 3 column totals, add them together to get 830. The other way of getting this is to take each one of these 6 cells here, add all 6 of those together, and that would give you also 830. So that's 3 different ways of getting 830. That's not the big deal anyways. I think there was a typo here, or in the answers it said 300. That's a typo. There are answers in the email. 830. Part B, marginal distribution for gum flavor. Okay, so gum flavor, you want to take the totals for each gum flavor and divide it by 830. So this part right here, this is question 2. The marginal distribution for gum flavor. The marginal distribution for factory production, however, is you take the factory total and you divide by the grand total. So maybe I can do it like this. This part is part B, or question 2. This is question 2. Hang on. This is question 2. That's question 2 right there. Okay. Question 3 is this marginal distribution right here. That's question 3. Here's question 2. Question 2, question 3. That takes care of that. Yeah.
For the charts for the test when we're filling them in, or I guess it'll be multiple choice, but if it's like a free response and we have to make a chart and it says marginal distribution, can we just put the percentage next to the total? Do we need to make like a row for the marginal on the bottom and marginal on the
It'll be clear what to do.
Okay. Like will it already be
It'll be clear what to do. Question 4. Conditional why does that say 300? 830. Okay. Question 4. What's a conditional distribution of gum flavor given that the gum comes from factory A? So we're saying from factory A, what's the distribution of gum flavor? So we want to divide gum flavor by the total for factory A. That's 250 out of 450, 150 out of 450, and 50 out of 450. So that's this right here. Spearmint is 56%, cinnamon is 33%, wintergreen is 11%. Okay? Comes from factory A means divide by the total for factory A. Okay. Let's take a look at the next few questions. You have a chart. You don't have the totals. You're going to have to get those totals somehow. So here they are. How many respondents were there? There were, how many female respondents? 6. How many total respondents? 7. The percentage of females among respondents. Okay, out of the 4,877, 2,252 of them were females. That's about 46%. Okay? Questions on any of that so far? You just kind of burned through those. Okay. Question 8. The percent in 7 is part of which distribution? Well, we're dividing a total, right? A total of the column. Oh, we've divided by a grand total, right? Okay, so because we divided by a grand total, this is a marginal distribution for respondents' sex. Okay? Next, question 9. What percentage of females were almost certain to be married in the next 10 years? Okay. Well, how many females were almost certain? 756 out of the 2,252. So 76 out of 2252 is about 34%. Okay. Question 10. What did we divide by? Well, we divided an amount of marriage chances by a total for the respondent's sex. So that means we're doing we're not dividing by grand total, we're dividing by a subtotal. So if you divide by either a row total or a column total, you're getting a conditional distribution. You're getting a conditional distribution for the row or column. So, in other words, we're doing a conditional distribution of marriage chances for the females, or given respondent was a female. So it's a conditional distribution. (11) What percent of those who thought they were almost certain to be married were female? Well, 1,930 people thought they were almost certain to be married. Of those 1,930, 756 of them were female. So we have 756 divided by 1,930. That's about 39%. So what did we divide by? We divided by a total for marriage chances. So it's a conditional distribution given marriage chance or for marriage chance. So it's a conditional distribution of respondent sex for the marriage chance almost certain. That 21 is supposed to be a 12, isn't it? Answer questions 5 through 21.
Yep.
That's supposed to be 5 through 12. Let me change that. What other typo did we have? I feel like there was another one.
The 2 Y's. No.
Oh yeah, the 2
Recycled.
Y's and recycled.
After number 16, there's a 3.
Yeah. That it?
I think so.
Yeah, I think you're right. Okay. Huh? No. Maybe I was. I don't know.
I can't remember
There was
the sheet that
didn't have typos.
there's always a reason.
One day.
One day.
One day. You get the one. Yeah. Yeah. When we get to that question, we'll go over them. Okay. 13 we just did, right? Alright, so that's 13. Let's look at 14. Okay, 14. Admission records at Berkeley were kept in 1973. They discovered a lower admittance rate for females when compared to their male counterparts. Ooh, bad Berkeley. They can't even play the fight song correctly. Damn. When examined further, females that year were applying to majors that had higher than normal denial rates. So in other words, they were getting into harder majors, or they were applying for a harder major to get in. Okay, considering that the admittance rate is a response variable and gender as an explanatory variable, what kind of relationship would this be? Were there 2 causes or 2 effects? Looks like there were 2 causes. So 2 causes means confounding relationship. And then I have this over here, same thing. If there are multiple causes, that's a confounding relationship. Warner, this is part of yours, right? If there are multiple effects, then that's an example of common response. Multiple effects.
Wait, so would the 2 causes be that they were female and that they were applying to harder majors?
Yeah.
Those are the only 2 relationships.
Well, there's also the causal relationship.
Which is a direct.
Causal relationship would be cause and effect. Do we need to go over that kind of that chart, or do you understand, kind of? Do you got that? Okay. So it's just that if you have multiple causes, that's confounding. Multiple, yeah. If the cause is really an effect. Yeah.
The population growth affects the
Yep.
number of high school grads.
Mm-hmm.
Alright, that makes sense.
Okay. And I think that's a good one to think about. If the alleged cause is actually an effect, then that's the common response relationship. Mm-hmm.
The last, why is it not called the other one?
Confounding. Because there's only one cause that has the effect. One effect is our alleged cause. So our cause isn't actually a cause, it's actually an effect. Okay.
115.
So let's see. Confounding relationships. Well, what's a confounding relationship that we saw? No, I mean, what's an example of the confounding relationship?
I remember the one you told me about the blood pills.
Yeah. Is there something else that works compared to that one? Gotcha?
I don't know how you would do that.
Wait, for confounding?
Confounding, yeah.
Like, is that like if you eat a donut, you get fatter, but it could be also that you eat a lot of.
No, you could exercise.
So you don't exercise. Yeah, you can be naturally fat.
Because of genetics, or you're
Like you can have an obesity disorder, but you also eat a lot of donuts.
Mhm.
Is that confounding?
that can be confounding.
That's confounding, yeah.
Oh,
That's confounding.
I've been thinking about that.
I really don't want to write it, though.
It's totally.
You're not writing, you're typing.
Typing. Okay.
Super casual is just like
Causal.
causal.
Also causation. Causation is the same thing though.
Well, it's just
Causation.
Like something affects something, and then
There's a
cause.
we're studying the cause and its effect.
Just
That's the direct one.
Yeah, that's the direct one. Okay, and I think what happened here is we made a boo-boo. When I say we, I mean me. I put the wrong chart up there. So really, let's see. Let's move this down here. That goes in there. This arrow does that. This arrow does that. That's great. That's perfect. Okay. So actually, for that question about, oh yeah, high school, number of high school graduates and cigarette sales. It's crazy. You can like pick any two variables, and if they're both related to population growth, there's your there's your common response relationship. Okay. Most things would be affected by something like that. Okay. So the number of high school grads is actually, so this diagram tells us that we think that the number of high school grads affects cigarette sales. That may or may not be true, and in fact it's not completely true, because what's happening here is the population growth is affecting the number of high school graduates. The population growth is also affecting the number of cigarette sales. So you have one cause, two effects. Our purported cause is actually an effect. So this is common response. Common response. Since there are two variables, wow. There are two causes.
So between one cause
No, there's
One cause.
one cause. And our alleged cause was actually an effect. There are two causes. What we thought was a cause was actually an effect. This is a common response relationship. Oh my god, that's the last question, isn't it?
Yep. We're done.
Wow, okay, I'm shocked. Thank you, everyone. How? What?